All right, you guys need help with anything? Guess what? 3 and 4. Tres y cuatro. All right, so for number 3, we have 2 trapezoidal prisms. The volume of the small. What?
These take forever.
I don't think that they actually do. No, I don't think they do take forever to do. So the volume of the small prism is 324 cubic centimeters. Okay, and then it says the area of the base and the area of the small. We're just going to go area small, area large. I warned you about this one yesterday. That this was going to happen. That you would be given the volume and asked to find the area, or you'd be given the area and asked to find the volume. Okay, so first of all, they give you the volume of the small prism, they give you the ratio of the areas, and then you are asked to figure out a ratio of the heights. So if you know the ratio of the areas, how do you find the ratio of the sides? You really don't know? Or are you saying that? Oh, did you say that?
Oh, is that simple? Oh, so it's
Hi, Greg.
right?
Hey, thanks for the baklava. Had that at lunch.
Yeah,
A little messy, but delicious.
More.
Okay.
yeah, I want some.
You're going to need to wear what? Okay, good deal.
What is it?
Yeah. What is what?
What did he give
Baklava?
Maybe some baklava. It's like
It's like
dessert.
It's a really nutty Greek pastry.
A really nutty Greek pastry. Really, really sweet and delicious. Okay, did you have a solution for us here? Okay, it's area, so it's got to be square root, because area is squared, so I'm going to do the square root. So the square root of 9 is 3, and the square root of 25 is 5. Okay? Then it says, what is the volume of the large prism to the volume of the small prism? Well, now that we know the ratio of the sides, we can easily figure out the ratio of the volumes. Just cube them both. And the only thing they did that's kind of wacky here is this is the smaller one over the bigger one. And then when they asked you to figure out the volumes, they said bigger one over the smaller one. Okay? So 3 cubed is 27. That actually goes on the bottom. 5 cubed is 125. That goes on the top. All right? Okay, and then now for the last part, we need to use that to figure out the volume of the large prism. So we're going to take that ratio, 125.
121.
Oh, you are so funny, Richard. Funny looking that is. The volume of the large one divided by the small one. And they tell us the volume of the small is 324.
Oh.
Right? That was the very first thing that they told us. Okay? And then we need to use that to figure out the volume of the large. So cross multiply and divide, and you should get a nice, pretty whole number. Very friendly answer.
1,500?
What?
1,500.
1,500. Okay? Okay, now we're doing the same thing with cylinders. So it says the volume of the large is 4,608 pi. And then we are asked first thing off to figure out the volume of the small cylinder. Well, guess what? We don't have to use ratios to figure that out, because they give us the dimensions that we need. What is the formula for the volume of a cylinder? But it's not 1/3 because it's a cylinder, not a cone, right? So it's just straight old area of the base times the height. And what is the shape that the base is? Circle. So the formula for the area of a circle is pi r squared. Okay. So what's the radius 9, what's the height? 24, so if you do that out, you get a volume of 1944 pi. Okay? So that's the first thing that you're supposed to figure out, and you don't need to do anything that we learned in this chapter to do that. Same with the next. Now it wants you to figure out a ratio between the volume of large and the volume of small. So that would be 4608 pi over 1944 pi. Okay, pi's cancel. Now Blake and I were working on this together yesterday, and you can divide those and get a decimal answer, but they really want a ratio, they really want a fraction. So it's better maybe if you just reduce. So were you able to do that, Blake? Did you figure it out? What it reduces to? No? So what number goes into both of these evenly? 2. So you start with the easy one. It's going to take us a while at that rate, but that means 2,304 over 972. Okay? What goes into both of those evenly? 2. So 1,152 over 486. What goes into those evenly? This is so fun. 5. I give you 10, leave you 1, 5, 7, 576 over 243. Okay? Aha, now we have a 3, so 2 doesn't go in there evenly anymore. What goes in there evenly? Now, 3. 192 over 81. Okay? What goes into both of those evenly? 3 again. That would be 18, so yeah, 64 over 27? No. Yes? Yes. Okay, and how about 64 over 27? Anything going to both of those evenly? No, now we're done? Okay. I got to cube it? No, I don't. I like to cube it.
Well, would be the easier way? Let's have go. How many times are we going 2 and 2 and 2 and 2 and 3?
What?
Like, how would it be easier to have we go like 2, 2, 2 and 3?
What's the easier way to do it?
Yeah, there's no other way.
Well, you could pick a bigger number that goes in there evenly to start with. Okay, like 2, 4, 12, 36 or something, you know, and then it would just make it shorter. Okay, so that's the ratio of the volumes. Now we need to use that to figure out the height of the taller cylinder. So give me a ratio I can use for that. And this is where the cubing comes in. What's the ratio I can use for that? Don't all say the answer at the same time. Give people a chance to like think about it.
We're thinking.
Okay, stop thinking now and say. What's the ratio, like, even with the 24 and the H, just get us going and then we'll. What? Okay, now where's the 3 and the 4 coming from? So Blake says, well, look, this is volume, right? So for us to talk about the sides, what do I need to do to these numbers? Cube root them, yeah, because volume is cubed, so I can do the opposite and cube root. So 64, the cube root of that is 4. 27, the cube root of that is 3. Okay, good, that's all we needed to get us started. So what goes with the 4, the H or the 24? The H, because it's from the bigger one, and the 4 is bigger than the 3. And so that means the 24 goes on the bottom. And so that means that the height is going to be 32. Okay? Rich?
Sorry.
Stop talking.
Sorry.
Can I do what, where, how, and when?
9 and 10.
5, 6, and 7. So are we still struggling a little bit with this?
This whole chapter.
No, it's the 6 and
This is nuts, Hannah says. What's that? Sweet deal. Thanks. All right, number 5. The ratio of the lengths of corresponding edges of two similar triangular prisms is 5 to 3. Okay, how do you do it? You what? Yeah, because it says what's the ratio of their volumes, and volumes are measured in cubic units. So you have to cube it. So 5 cubed is 125, 3 cubed is 27.
That's it?
That's it. Okay? Number 6 is the same thing, but go backwards. Number 6 says the ratio of the volumes is 8 to 125. What is the ratio of their height? So you have to 2. Cube root of 8 is 2. 2, 5. Okay? So if they tell you the ratio of the sides and you want the ratio of the volumes, you need to cube it. If they give you the ratio of the volumes and you want the ratio of the sides, you need to cube root it. Alright, and then I'm guessing 7 is the one where we have to do it both. It says, oh, the ratio of the weights of two spherical steel balls is 8 to 27. What is the ratio of their diameters? Well, what physical characteristic do you think weight is related to? Volume. Yeah, the more volume you have, the more you weigh. So instead of saying, do these pants make my...
Volume like that?
Yeah. Do these pants make my butt look like it has large volume?
No, this is
voluminous?
pants make my butt take up lots of volume.
Do that to your boyfriend or husband. They won't know what to say. So that's basically the ratio of the volumes.
I'll just use say perfect volume.
You have perfect volume. Yeah. So you what? Cube root it. Yeah. So cube root of 8 is 2. Cube root of 27 is 3. Yeah.
9 and 10.
9 and 10 is that it?
Yep. Because
Sure.
this is a sculpture. How do you do that?
Okay, number 9. The sculptor creates a small bronze statue that weighs 38 pounds. So once again, when they tell us the weight, they're referring to the volume type of thing, right? She plans to make a version that would be 4 times as large in each dimension. So she's going to take the height and the width and the depth and make it all 4 times as large. Okay? So the question is, if you make all of the dimensions 4 times as big, how much bigger are you making the volume? 64. I thought you had it because you went with this, and I thought it was going to be 64, but it was a 16. So, yeah, because what do you have to do to this number? What do you have to do to this number? Thank you. What do you have to do to this number? Cube it. And 4 cubed is 64. So to find the new weight,
1444.
what is it?
1444?
1444. Nope.
I guess 24. 2004.
2432.
Yeah, it's 150. That's the engine though.
Okay, now the best one is the super chicken. The super chicken. All right, number 10. A tabloid magazine at a supermarket checkout exclaims, "Scientists breed 4-foot-tall chicken." A photo shows a giant chicken that supposedly weighs 74 pounds and will solve the world's hunger problems because there will be chicken for everyone. And as we're eating our barbecue chicken, we'll just laugh at the vegetarians who are all starving. No. What do you think about this headline? Assuming an average chicken stands 14 inches tall, so the height of your average chicken is about 14 inches tall, and the weight of your average chicken is 7 pounds, is it reasonable that a 4-foot chicken would weigh 74 pounds? Okay? No, and here's why. If we want our new height to be 4 feet, how many inches is that? 48. So, how many times bigger than 14 inches is 48 inches? Is it 4 exactly?
No, I think it's 3 point something.
It's like
Yeah, I think
3
it's
point
3 point something also. It's 3.4? Okay. 3.4 repeating? 3.428. Okay, so 3.4 is probably pretty good. Okay, so if it is 3.4 times as tall as it was before, just like in the statue problem that was 4 times as tall as it was before, what did we do to that to figure out how many more times it would weigh? We cubed it. So you have to do the same thing with this number right here. So it's going to weigh 3.4 to the third times as much. What is 3.4 to the third?
39.3.
39.3 for reals?
Yeah.
Okay.
Wait, I thought you were supposed to set up a one.
You could do that. Would you like to do that?
Okay, wait, what's 14 over 7 equals 48 over 74?
14 over 7 equals 48 over 74. No. Because the 14 and the 48 are both lengths, they're both heights. And so if you're going to compare them to the volumes, what do you need to do first?
So you have to do
You have to cube it. Okay? So when you said 14 over 7 equals 48 equals what? No. Yeah, equals 48 over, well, really it would be x, right? Because we're trying to figure out the weight. Okay? You would have to cube these both before you cross multiply. Okay? Yes, and the response that your eyeballs is doing is the correct response, because if we go with this other way where we just take the number of times taller it is than it was originally and cube that, if our original chicken weighs 7 pounds, how much does our new chicken weigh? 275 pounds. Okay? Okay? Think about it. 275 pounds. Who weighs 275 pounds?
Me.
Not even like large humans, yeah. Okay? I'm the most voluminous guy in the room and I don't weigh 275 pounds. How much do I weigh? I'm not going to tell you. Too embarrassed. No, I weigh about 220. What do you got, Margo? I got 220. What do you got? 205. That should be better. 250 for reals? Oh, dang it. All right, let's start working out. Anyway, we're talking about a 4-foot chicken that weighs more than Greg. Okay? That's crazy. Could you possibly have a 4-foot chicken that weighs 275 pounds? No, because its bones would just be crushed under its own weight. Have you seen chicken legs? Okay? So it would not work. All right? So nature has imposed some physical limits on that. So, is it possible for the chicken to be 4 feet tall? No. No. Would not be able to support its own weight. If it was sitting down the entire time, yeah. But then even its like internal organs would get crushed. That's one big chicken. Okay, so turn those in and I guess we'll go worksheet again.